What if I told you that we are closer than ever to building a real space station not in Earth's orbit, but on Mars itself, on a barren, frozen, radiation-soaked world over 140 million miles away? Imagine astronauts living and working inside pressurized domes, growing food in Martian soil, 3D printing their tools with dust from the red surface, and communicating with Earth using laser beams across the void of space. Sounds like science fiction, right? But with Elon Musk's Starship, NASA's Artemis plans, international space agencies joining forces, and breakthrough technologies in robotics, AI, and sustainable energy, this fantasy is turning into an engineering blueprint. In this video, we are going to take you step by step through what it would really take to build a full-scale space station on Mars. The mind-blowing science behind it, the terrifying obstacles, and the bold missions already setting the foundation. Buckle up, because by the end of this video, you won't be asking if we can build a space station on Mars, ... You'll be wondering when. For decades, Mars has called to us like a mythological god of war, its red hue glowing with mystery and challenge. It's harsh, unforgiving, and deadly. And yet, it's our most promising destination in the solar system for human colonization. But let's not jump ahead to cities and colonies. Let's talk first about something more achievable in the near future: a permanent, manned space station on Mars. Unlike Earth's orbiting International Space Station, a Martian space station would be rooted to the ground of another world, battling not only microgravity but also deadly radiation, dust storms that last for months, frigid temperatures down to -80 degrees Fahrenheit, and a paper-thin atmosphere filled with carbon dioxide. But despite all that, building such a station is not only possible, it may be necessary. Why? Because Earth is vulnerable. Between climate change, potential nuclear war, asteroid threats, and pandemics, humanity's survival hinges on becoming a multiplanetary species. This isn't just an engineering challenge, it's a survival imperative. Mars is uniquely suitable for this vision. It has water, ice, has day-night cycles similar to Earth. It has seasons. It even has some protection from solar radiation thanks to its thin atmosphere and occasional magnetic pockets. And most importantly, it's reachable. With current propulsion systems, we can reach Mars in 6 to 9 months. And with upcoming technologies like nuclear thermal propulsion and ion drives, that time could be cut dramatically. But before we get there, we need to ask, what exactly would it take to build a space station on Mars? Let's break it down into 5 massive pillars: location selection, construction and materials, life support systems, power and energy, and long-term sustainability. And each of these categories hides 1,000 mind-blowing details and innovations. Choosing the right location on Mars is not just about picking a spot that looks cool on satellite images. It's about survival. The best candidate locations must meet specific conditions: stable ground for construction, access to subsurface ice, moderate elevation for decent atmospheric pressure, and ideally some shielding from radiation. One of the top choices among NASA scientists is the region known as Arcadia Planitia. It's relatively flat, sits in the northern hemisphere, and has confirmed subsurface ice deposits. Another popular contender is near the equator, such as Elysium, Planitia, or even Gale Crater, where the Curiosity rover is currently exploring. Equatorial regions offer more sunlight, which is crucial for solar energy generation and milder temperature fluctuations compared to the poles. Then there's the consideration of Martian weather. While Mars doesn't have Earth-like storms with rain and thunder, it does have planet-wide dust storms that can block sunlight for weeks. That's why building underground or partially underground could be a game-changer. Lava tubes, natural tunnels formed by ancient volcanic activity, have been discovered on Mars. These could serve as ready-made protective shelters from radiation and meteor impacts. Imagine building the first Martian station inside a lava tube: ready-made insulation, shielding, and even acoustic protection. So, we've chosen a place. Next comes sending construction materials from Earth to Mars is not just expensive, it's almost impossible at scale. A single kilogram costs thousands of dollars to launch. So, space agencies are investing heavily in Insight to Resource Utilization, or ISRU. This means building with what's already on Mars. The Martian regolith, the dust and soil covering its surfaces rich in silica and other minerals. Scientists have found ways to turn this dust into bricks using 3D printers and microwave sintering. NASA has already tested prototypes that convert regolith into strong, insulating materials. Imagine autonomous robots landing ahead of humans, 3D printing entire habitats out of Martian dust. These robots could work for years, powered by solar or nuclear energy, assembling domes, tunnels, and support structures all before the first astronaut even arrives. Inflatable habitats are also on the table. These are compact structures that expand on arrival, providing instant shelter. Once set up, they could be reinforced with regolith bricks or covered with protective foam sprayed by drones. And let's not forget SpaceX's Starship. With a payload capacity of over 100 tons, it could carry prefabricated modules, solar panels, food supplies, and even rovers. Multiple starships landing within a kilometer of each other could serve as the base infrastructure of the first Martian space station, connected by pressurized walkways and underground tunnels. But construction is only the beginning. Living on Mars is not like camping in the desert. The real challenge? Keeping humans alive indefinitely. Real question. How do we build anything on a planet that's 140 million miles away? Every breath we take, every drop of water we drink, and every calorie we consume has to come from somewhere. On Earth, these needs are effortlessly met by our planet's ecosystems. On Mars, they require engineering miracles. Oxygen won't come from oxygen tanks. That's unsustainable. Instead, NASA's MOXIE experiments successfully tested on the Perseverance rovers leading the way. MOXIE extracts oxygen from carbon dioxide, which makes up 95% of Mars' atmosphere. Scale that up, and we can produce breathable air indefinitely. Water is a bit trickier. Martian ice exists in polar regions and just beneath the surface in certain areas. Heating and filtering this ice can yield potable water, but the energy required is massive. That's why water recycling down to the last drop is essential. Closed-loop systems, like those used on the ISS, recycle sweat, urine, and even exhaled moisture into drinkable water. Yes, it sounds disgusting, but it works and it could save lives. Food production is perhaps the most complex issue. You can't grow apples or carrots in Martian dirt, at least not without massive intervention. But hydroponic systems where plants grow without soil and nutrient-rich water could feed crews for months. Researchers are even experimenting with Martian simulant soil, enriched with microbes and fertilizers to make it viable for agriculture. With vertical farming, LED lighting, and AI-controlled temperature and humidity, we may grow spinach and potatoes on Mars within the first decade.